Fantastic. So, hello everybody. My name's Dom. I'm a anaesthetic registrar working at Leeds at the moment, and I have been given the glamorous and sought-after post-launch slot for this mini seminar. So, I hope everyone is well fed. I'm going to try not to be too heavy on the technical details, and instead of that, I'm going to talk about the project that I've done and how potentially you might be able to use it in your organizations if you become part of the course next year. So what this is, it's another discrete event simulation model, also using a web app in Streamlit. And as we've sort of discussed a little bit earlier on, so discrete event simulation is really about modeling queuing. So you've got entities, which we commonly use to represent patients. They'll enter into this pathway, and they then queue while they wait for certain things to become available, and they need to get to the front of the queue before they can move to the next step in the pathway. So as an anaesthetist, we spend a lot of time looking at elective surgery and waiting lists, and we thought that it'd be interesting to look at the referral process and the pathway that patients go through to get to theatre. So what we've got here, you can see this diagram. It's more of a high level concept. It's a model of a possible pathway rather than any specific pathway. But you see the idea. You get referred by your GP. You then wait to be seen in a clinic. Then you might need, let's say, some sort of imaging like an X-ray or CT. You might need to have some sort of physiotherapy or other kind of therapy beforehand. And then once you've gone through all of those things, you are booked on for your theatre list, which you also have to wait for that to become available. So what we did was we basically made a simple model of this. And the question that we wanted to answer, because this was initially looking at a particular pathway for hand surgery, and we wanted to look at what difference it would make if there was a possibility of adding on a couple of extra patients per week. There was an emergency list that had a bit of extra capacity. We wanted to see what the possibilities would be there. So you can see all of these inputs are entirely customizable. So it's a great way to demonstrate to non-technical members of staff what's possible. You can put in, the number of clinics, the number of imaging slots, the number of appointments per clinic. And this model actually pre-populates each queue before you start. Now, another way of doing that is to just start with all the queues empty and then run it for a period of time and let them fill up. But we chose to pre-populate them based on the patients that we knew were waiting in those queues. So you can just press the button here, and it does take just a minute, but then it will generate the results. And it's very easy as well using Streamlit to generate really nice graphs that are very easily understandable to demonstrate the results of each one of your simulations. So this is the sort of default position as we started. So you can see we start with 2,000 patients on the waiting list. We run the simulation for 100 days, and at the end of that, we've got nearly 3,000 patients waiting. You can see on this graph here, there's this red line is the waiting time per patient, which has got steadily higher over that time, going up from about 1,700 to about 1,800 days. And you can see the numbers in the waiting lists here, and this is a nice sort of interactive graph that you can hover over as well, and different people waiting at each stage of the pathway. So then it's very easy for us to say, right, well, if we could go, let's say, 3 times a week and squeeze one extra patient onto this emergency list, so take one elective patient and just book them on at the end of the list if there's capacity. So what would the impact be, everything else being equal? And you can see here, we've now got we're still starting with 2,000 patients waiting. But then at the end of 100 days, we've actually reduced that to 1,700. The waiting times are not so different. Well, the trend is similar, but the actual waiting time is reduced quite substantially. So that's now down to about 1,300, 1,400 days on average. And you can see as well, compared to the start and end of the simulation, the number of patients waiting for the theatre list has really come down quite a lot. Meanwhile, the number of patients waiting for therapy or imaging has actually increased. So this also kind of suggests that if you wanted to get further benefits, you might have more of a benefit by increasing the amount of imaging slots available rather than more increase in theatre capacity. And that's something that you could model as well. So that is basically, that's the model that I've come up with. And this is something that is going to be made available to you guys. So a large part of getting this model made was just making the code work, getting it to play nicely with Streamlit, working out the bugs, and all of that is sort of done now. Now, this is a very simple pathway, but it's quite easy to kind of scale this up if you want, perhaps there's multiple paths that you might go down. Let's say if there's patients could either go for main theatres or day theatres, you could look at how that would divide up. You've seen Becky's model this morning, looking at AMU. People have looked at flow through A&E before. It doesn't even have to be patients. It could be something like, if you work in pathology, it could be something like the path of a blood sample going through from where it's collected, needs some processing, then needs to be reported. So all of those kind of things, you could start with this framework and expand it or customize it to whatever you need. So that is basically what I've got to show you. And I'll just quickly say what I know everyone else has been saying, but I really recommend the course if this is something that you're interested in. I'm a clinician, you don't need to have a data science or BI or analytics background in order to do this. It's a really great broad sweep covering a lot of topics, and you can pick out whatever you're particularly interested in. And for those medics in there, this project has been really good for portfolio work as well. So I'll stop there, and I've got a couple of minutes for questions.